Hey, what's going on, everyone? This is Jacob with devslopes.com, and today I'm going to just do a short video on recursion and what you would use, recursive functions for and what it is exactly. Recursion, like the textbook definition for it, is recursion is the process of repeating items in a self-similar way. So something that you would use like a loop for or any kind of iteration like that, you could probably use a form of recursion to solve the same exact problem. One thing you want to think of with recursion, though, is it is very expensive when it comes to memory. So if you're calling the function more than 1,000 times, you probably don't want to use a recursive function. But I'm going to show you some examples, and let's go ahead and open up Playground. Okay, so I just opened up Xcode Playground. We'll make the screen bigger. Okay, that should be good. I'm jumping into a simple example here using a for in loop, and then we'll show you how you can solve the same thing with recursion just to get our feet wet. This isn't the best example because the purpose for using recursion is to usually like make your code cleaner and easier to read. And with Swift these days, the way that a for in loop is now written, it's pretty clean and easy to read. But we'll do it anyways, just so you can understand what's going on. So if we just write a function here, print numbers, we're just going to print numbers to the screen. And we're going to make a simple for in loop for x in 0 ... max. And we're just going to simply print x. And let's open up the bottom here. And now we will say print numbers. And why don't we just toss in 3? And, like you're familiar with, you get your count 0, 1 through 3. All right, so how would we do this with using a recursive function call? It's pretty easy. So let's write a function here, and we're going to call this print numbers rec for recursive. And we can pass in another integer the same exact way as above. And here we just have to make sure the max is above 0. And right now, all right, so we're going to call our function. So, a function that calls itself from within itself, that's a recursive function. And what we're going to do here is we're actually going to call print numbers rec. And we're going to pass in the variable that already was passed in, which is max, but we're going to subtract 1 from it. And this kind of, as you can see, it's kind of the same concept as a loop already. So we can come down here outside of the if statement and print max. And it's going to iterate through the same exact way the for in loop did when we call it. So if we do print numbers rec, and let's pass for in just to show a little different. There we go. So it just printed 0, 1, 2, 3, 4. So this function is the same exact function as up here. And like I said, this isn't the best example to like why you would use a recursive call function, only because it's the same amount of code, if not more. But it's a good easy example to wrap your head around what recursion is. So I'm going to go ahead and delete this. Okay, now we can do a little bit more of a not really difficult recursive call, but this is exactly the reason why you'd probably want to use recursion over like looping through a for in loop. And what we're going to do is we're going to find factorials. And if you're not familiar with what a factorial of a non-negative number, it can't be negative, a non-negative integer. If you're not familiar with that, we'll just go over that real quick. So, I mean, back to middle school math. So a factorial is shown by the explanation point. If you remember this, like what would be the factorial of 1? Well, that is just going to be equal to 1. If we wanted to know the factorial of 2, it's 1 times 2. And that would equal 2. And then as you go up, factorial of 3 would be 1 times 2 times 3. And that equals 6. All right. So, I mean, obviously, like for smaller numbers, this is really easy to do. But you know, already when you get to 7, you're doing 1 times 2 times 3 times 4, 5, 6, and 7. That can get pretty tedious, and you start getting large numbers here. So that's 5,040. Now, if we were to do this the old, like not the old-fashioned way, but if we were to do this with a for in loop, we end up writing a lot more code, and we're going to do that. I'm going to write the for in loop just so you can see the benefits of using recursion. So let's see. We need a variable first that is going to keep track of our multiplication solution. So we'll just set that to 0. And then let's make our for in loop. And we want this 1. We don't want 0 in there. So 1 through whatever number we pass in. And then if the factorial is not equal to 0, we are going to set the factorial variable equal to what value is already stored in our variable times x, so times the iteration that we're going through in our for in loop. Now, if it is 0, we need to set our factorial variable to 1. And then we can go ahead and return our factorial variable. So, you know, it's not a lot of code, but it's still a decent amount. And why don't we just test this? We already know the factorial of 7. Let's see, where is my size? So the factorial of 7 was 5,040. So that worked. This solution works for us. Okay, so if we want to use this with recursion, we have to think through what we want to do. We want to take the number that we're passing in, and we have to multiply everything from 1 to that number. The number we pass in is the max. So let's think this through. We can write the basic function out. So we're passing in an integer, and we also want to return an integer, just like before. All right, so far everything's the same. Now, at some point, we want to return the number that is being passed in times, you know, every single number. So from, you know, 7 to 1. So it's pretty easy. We just have to call our factorial function and pass in the number again, but minus 1. So just like the how we iterated through the numbers and printed 0 through 3 before, it's the same concept. There's one problem with this, though. If we try to call this, it's not going to work very well. So we probably have to think about this like, okay, like up above, we have to make sure it's above 0, or well, like 1 times 1 or 1 times anything is the same number. So maybe we should just check for if the number is equal to 1, we can return 1, and that'll take care of you know, the smaller numbers as we approach 1, or it won't allow us to go negative either. But then we need to return this. Whoops, sorry about that. Bracket. All right. Cut and paste. All right, so if we pass in the same number now to our factorial, let's pass in 7, and we should get 5040 again on the right side here. Yeah, so we did. So this was called 6 times, starting with 2. So we basically ignored 1 because we know that 1 times anything is going to be the same exact number, and that prevents us from going into the negative numbers. If we hit 0 or -1, this function wouldn't work. And yeah, so, and we would have ran into the same problem here. But so the point of recursion, we have 1, 2, 3, 4, 5, 6, basically 7 lines of code. Finding the factorial with recursion versus 1, 2, 3, 4, 5, 6, 7, 8, basic versus 11 lines of code. So it makes it a lot easier to read. When I first learned about recursion, I wanted to use it in every scenario possible. It's not that realistic, but there are certain circumstances where it works out perfect, and it can be a pretty powerful tool. It's cool. All right, so obviously, like with recursive calls, it can get really confusing. I try to use really basic, simple examples for today because they can get very confusing. But a good place to practice, where you can use a lot of these skills and practice using it, is Project Euler.net. I like to go here. They have awesome little like mind exercises. It makes you start thinking more like a programmer and like solving problems, and it's pretty cool. You would log in and you just go through, you go in order, you know, 1 through whatever, and after the first 2, after the first 3, this gets pretty darn difficult. But you can use like recursive function calls in a lot of these problems to make them easier to solve. And I would definitely recommend checking it out. That's projecteuler.net, and it's awesome. Yeah, and my name is Jacob with devslopes.com, and I hope you enjoyed this video.